On this next problem, it says use composition to show that the following functions are inverses of each other. Okay, so again, I'm going to be using colors. I'll use green and orange. So this is a prove problem. It says show. So this is another way to say show is prove. Okay, so you have to use composition because that's what it told you to do. It also says show that they are inverses of each other. So if you are looking at the verbiage here, you know the answer is yes, they're inverses of each other because of the way I phrased it. Use composition to prove or show that they are functions of each other. So I know the answer is yes, okay? I just got to prove it. The way I prove it is to evaluate f of g of x and then evaluate separately g of f of x. Hopefully, if I do this correctly, then I'll have x at the bottom, okay? If each one of these is equal to x, then I know that they're inverses of each other. If one of them is not equal to x, then they're not inverses of each other, but I just told you that they are because the verbiage tells you, hello, they are, so you just need to prove it, okay? So let's just do one of them, f of g of x. Well, g of x, I can replace the orange with x minus 4 over 3. Then I have to evaluate f at x minus 4 over 3. Well, the f function says 3 times x plus 4. 3 times x plus 4. But who is x? X is the orange x minus 4 over 3. So I've worked it out. Now I just have to simplify it. So the thing about simplifying is a lot of times people will just like slash, 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 and just say, oh, it's x. Okay, you can't do that. You actually have to show me what divides out with what, which means you have to do this in 2 steps. I know the 3's are going to divide out, and I know the 4's are going to add to 0, but the order matters. In this case, because there's parentheses, this 3 and this 3 divides out first, and you get x minus 4 plus 4. Now that the plus 4 and the minus 4 are on the same level, in the same, because the parentheses are gone, now they can add to 0 and get x. But you first have to cancel the 3's out on the first step. Then you can add the 4's to 0 on the second step to get x. You can't do that all in one step. I'm looking for that on the exam, that you have that in 2 steps. Let's do this all over again, except in the other order. G of f of x. Now f of x is equal to 3x plus 4, so I can replace the f of x with 3x plus 4. Now I'm going to do the g of x function. The g of x function says x minus 4 over 3. X minus 4 over 3. But I'm taking the x out, and I'm replacing that x with whatever is inside the parentheses, which in this case is 3x plus 4, and then minus 4 all over 3. On this problem, the 3's do not divide out. And the reason the 3's do not divide out right now is because you have 2 4's on the top, and 4 divided by 3 is not the same. So what needs to happen here first is you need to take the 4 plus 4, because they're on the same level. The 4's add to 0 first, and then you're left with 3x over 3. Now that there's only one term in the top, one term in the bottom, then the 3's divide out and you're left with 1x. Because they're both equal to x, we can say, therefore, f and g are inverses. Okay, and that completes the problem. Just make sure you're doing the canceling in 2 steps, not just 1. This next section says to use transformations of basic functions to sketch the graph of each function below. And then make sure you use the key points. Now, I don't think there's going to be 5 problems of these on the test, but I gave you 5 because there's 5 basic shapes on the review. So just don't expect them to be this many on the test, but I just want to make sure you're prepared for all of them. So the cube root, that's this shape right here because of the cube root. Okay. The horizontal shift, that's underneath the radical, opposite of what you might think, so that's negative 4. The vertical shift is the number after the function, so that's negative 5, exactly how you'd think it. Put those 2 numbers together, negative 4, negative 5, that's the vertex, which is right there. And the compress and stretch is the number out in front, which in this case is 1. Which means going back to my basic shape, I have a vertex, To get to my other key values, I'd go right one and up one, left one and down one. And that's exactly the same because my compress and stretch didn't change it at all. Now, these 3 points have to be correct. In addition to those 3 points having to be correct, you also have to have the correct shape, okay? So you have to make the shape like that. Now, a lot of students cannot draw that just like as smoothly as I drew that because they just can't. So what you can do is rotate your paper like 90 degrees and put your pencil on the blue mark and then just make a like half parabola. Now rotate your paper all the way in the other direction 180 degrees and then make another half a parabola. Technically they're not parabolas, it's a cubic function, but this is a cheating way just to draw it smoothly so it looks like correct. I can't tell you how many times I've seen students like, woo, and I can't accept that, okay? It has to be somewhat in the right shape. I'm not too terribly picky, but it has to be at least the right shape, and it has to have at least the right key points, okay? On our next problem, x squared, that's a U shape, okay? The horizontal is the opposite of the +5, which is -5. The vertical is the -2, which is on the outside. Put those two together, -5, -2, and that's your vertex. The stretch or compress is the number out in front, which in this case is 3. Because it's more than 1, it's going to be stretching my graph. So let's go back to the basic shape. To get the key points, normally I would take the vertex and go right one and up one, left one and up one. But there's been a change. Because there's a compress and stretch of something other than 1, the vertical values, because this is a vertical stretch and compress, right? The vertical values are now going to be 3. Notice the ones don't change. We're going to go left 1 and right 1, but instead of going up 1, we're going to go up 3. Okay, that's a vertical stretch and compress. There is such a thing as a horizontal stretch and compress, but we don't do that in this class. So you should know it's going to have to be a vertical. So right 1 and up 1, 2, 3. Left 1 and up 1, 2, 3. What happens when you stretch your parabola is it's going to get nice and skinny here. Technically, skinny is not the best word for it. It's more stretched. It's getting elongated. It's not pulling in, it's just getting elongated. Okay, one more here. Cube, x cubed. That's this shape right here. The horizontal shift, that's the opposite of whatever's inside the parentheses, which is +4. The vertical shift, that's if there was a number out here, that would be the vertical shift. But because there's nothing there, you can think of it like a +0. So your vertical shift is 0, so that's 4, 0 at your vertex. And the stretching and compress in this case is a half. Okay, let's go back to our basic shape. And I'm drawing these little like triangles here. I would highly suggest you do that on your paper. Normally go right one and up one and left one and down one. But because there's been a change, we have instead of going right one and up one, you're only going to go up a half. Instead of going left one and down one, you're going to go only down a half. So you cross out the ones and you're replacing them with a half. So I am going to do my best here to show you this. So you're going to go right one and up only a half. And then you're going to go left one and down, not one, but only a half. What happens here is when you get this compressed, it makes your cubic function look a little fatter than normal. Technically it's not fat, it's compressed, but it's kind of wider. It looks wider than what it normally would have.